Hi guys, you're welcome to today's exposition. Now today we're going to be looking at worked examples on kinematics. And don't forget that in a previous exposition we worked on equations of motion and we also worked on different terminologies on rectilinear motion, all under kinematics. So I gave you a couple of formulas and I urged you to go ahead and learn them because they will come in handy when it's time for calculation. And today we're going to be looking at a couple of calculations. So now look at this first question. A body starts from rest and accelerates uniformly at 5 meters per second squared until it attains a velocity of 25 meters per second. Calculate the time taken to attain the velocity. Now this question was given to some students during 2005 WAEC, West African Examination Council. So this is a physics question to test a couple of students that sat for WAEC, So now look at what I'm going to do first. The first thing we are going to do is to state out all the parameters, all the things given to us before we start calculating. So according to the statement, a body starts from rest. Don't forget that this is acceleration along x-axis and it's a one-dimensional motion. So a body starts from rest. So when a body starts from rest, it means initial velocity is 0. So we're going to state that out first. Initial velocity is 0 meter per second and accelerates uniformly. Now, when I say uniform acceleration, in the previous exposition, it was made mention unto us that constant or uniform acceleration of velocity simply means there's a maintenance of that very given velocity or acceleration. That means there's no change. It's been maintained over that period of time. So the acceleration is uniform. Acceleration is uniform. So acceleration is 5 meters per second squared. So you have to state them all out until it attains a velocity of 25 meters per second. So this is the final velocity, v, 25 meters per second. Don't forget, acceleration is a meter per second squared. Velocity is a meter per second. So what do they want us to get? They say calculate the time taken to attain the velocity. That is the time taken to attain or to get to the final velocity. So time is what we are asked to get. So time, which is a scalar quantity, is unknown. So we're going to be looking at all our equations of motion. I gave you 5 of them. So we're going to be looking at them. Among those 5 equations of motion, one of them will come in very handy to solve for time, So the first we have is v equals to u plus at, which is the first. And then we have s equal to v plus u. I'm just trying to state it out because I stated it out already. We should have it already by heart. We should have it by heart now. So the next we have is v squared equal to u squared plus 2as, equation 3. And also we have s equal to ut plus half at squared. I'm just taking them out randomly. And also we have s equal to vt minus half at squared, equation 5. So what do we do? So we are looking for time. We have initial, we have final, we have acceleration, and we have time. So each equation has all what we want, all what we need, all this parameter is equation 1, v equal to u plus at. So as you can see, there's v, there's u, there's acceleration, and there's time. So we can use this easily. And also, you could watch out for a couple of others. We could also use, we can't use this because there's no distance given. So this is the best we could use. So let's use equation 1, v equals to u plus at, equation 1. So final velocity is 25 meters per second. Initial velocity is 0 meter per second plus acceleration 5 meters per second squared times the time we are looking for. So what do we do next? The next thing we do, I'm going to call all our like terms. 25 minus 0 is 25 meters per second. Then acceleration 5 meters per second squared times time. So we are looking for time. We divide both sides by 5 meters per second squared. That's what we're going to do. So this divides this. So our time is 25 meters per second squared, I beg your pardon, divided by 5 meters per second squared. So what do we do next? This 25 m over s meter per second divided by 5 meters over second squared. So 25 meters per second times 1 over 5 second squared over meter. So second cancel this, m cancel m, that's a meter. 5 here 1, 5 here 5. What do we have left? Our time is 5 seconds. So this is as simple as ABC. Question 2. An Air Force jet flying with a constant speed of 335 meters per second went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? Now, this is another beautiful question. Now, this question was given in 1978 to some JAM students. Now, JAM is an exam written by Nigerian students, that will give them a pass to the higher institution. So this exam was written in 1978 by JAM candidate. So now look at this: an Air Force jet flying with a constant speed of 335 meters per second. Now, when we say something is constant, as I said earlier on, also in the previous exposition, that when that constant speed or constant acceleration of velocity simply means there is no initial and there's no final. It means the initial and the final are the same thing. When we say constant, it means there is no change. It means there is a kind of sustenance or a kind of maintenance of the same speed over a given period of time. So if this is a constant speed, it means the initial speed is 335 meters per second, and also the final speed is 335 meters per second. So I said an Air Force jet flying with a constant speed of 335 meters per second, 335 meters per second, went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? So the anti-aircraft gun was stationed somewhere, and immediately the Air Force jet flew past it. It was shot. So the question now is that 5 seconds later, how far do you think the Air Force jet would have gone 5 seconds later? So that's going to be time. The time for the whole event is 5 seconds. So how far means the distance. Where will it be? Don't forget that what we're working on right now is we're working on acceleration along x-axis. That's what we're working on. So what are we going to do next? We have our u, our v, our t, and our distance. So what equation of motion suits this the best? So I think equation 2 right up there is the best for this. So s equals to v plus u over 2 times time taken. So you're looking for how far that is the distance the aircraft would have gone 5 seconds later after it was shot at. So s is the distance. So final velocity is 335 meters per second plus initial velocity 335 meters per second divided by 2, then times time, which is 5 seconds. So when we do this, the next thing we do, 335 plus 335 will give us 670. Now if you divide it by 2, you are still going to get 335 meter per second, then times 5 seconds. So the distance, so 335 meter per second, just like this, times 5 seconds. Seconds cancel our seconds. So the distance is 335 times 5. 5 times 5 is 25. 5 keep your 2. 5 times 3, 15 plus 2, 17. 7 keep your 1. 5 times 3, 15 plus 1, 16. 1,675 meters. Or you could call it 1.675 kilometers. So that's our result. So I want to take note of something. Always watch out for your units. Units are very, very important. Distance is in meter. Time is in seconds. Acceleration is in meter per second squared. Velocity is in meter per second. So whenever we are given otherwise, we have to look for a way to convert them. So the third example, 2 points on the velocity time graph have coordinates 5 seconds, 10 meters per second, that's the first point, and 20 seconds and 20 meters per second, that's the second point. Calculate the mean or average acceleration between the 2 points. Now, this question was given in 1989 to some JAM students. Don't forget, JAM is an exam written in Nigeria by students who has aspiration to go to the higher institution. So look at this. 2 points on the velocity time graph have this coordinates, this and this. What is the mean or average acceleration? Now, this formula was given in the previous exposition. Average acceleration, don't forget that acceleration is a vector quantity. So average acceleration is always change in velocity over change in time taken. So what's that going to be? That will be final velocity, that's velocity 2, minus initial velocity, velocity 1, that's the first, over final time taken, minus initial time taken. So as you can see, this is time 1, velocity 1, time 2, velocity 2. So average acceleration right now is, what's the final velocity? 20 meters per second minus initial velocity 10 meters per second. All over final time 20 seconds minus 10 second minus 5 seconds, I beg your pardon, the initial time. So what's that going to be? 20 meters per second minus 10 meters per second. That gives us 10 meters per second over 15 seconds. 5 here 2, 5 here 3, the meter over second squared. So what do we have here? 2 over 3 meters per second squared. So if you convert this, you end up having average acceleration to be 3 into is 0.6666 and so on and so forth meter per second square. Now here's the fourth and the final example for today, exposition. Now look at this. A stone is released from a height of 80 meters above the ground. Calculate its velocity just before it strikes the ground. Now this question was given in 2003 to some NECO students, some NECO candidates. This is also an exam written in Nigeria. So now don't forget, this question is for acceleration of bodies under gravity effects, that's along y-axis. A stone is released from a height of 80 meters above the ground. Calculate its velocity just before it strikes the ground. Now this is a different kind of question. As I said, don't forget that we are working on one-dimensional motion, rectilinear motion. So even the first three examples, we worked on acceleration along x-axis, that's acceleration of bodies from rest. And right now, these very examples for acceleration for bodies that are under the effect of gravity. Either the body is falling or the body is rising. Now, whenever an object falls from a height, what does it mean? This is what it means. Whenever an object drops from a height down, it means that acceleration along y-axis, this is how we do it, acceleration along y-axis, all these ones up there, they are all along x-axis. Now, acceleration along y-axis, which is known as gravity often, is a constant 9.81 meters per second squared, and approximately it could be 10 meters per second squared approximately. So now that's the first thing you have to note. So if a body is falling down, acceleration along y-axis, I beg your pardon, is always positive. But if the body is rising against gravity, if the body is rising or going up against gravity, acceleration along x-axis is negative. For bodies that are falling, it's positive. Why is it positive? It's positive because of the fact that it obeys gravity. The law of gravity is that all object that goes up should drop down. So gravity pulls down object. So if an object is dropping, gravity is positive. If an object is rising against gravity, gravity is negative, at that very point in time. So that's the first thing I want to note. Very, very important. So if an object is rising, acceleration due to gravity, acceleration along x-axis is negative gravity. So now quickly let's bring out the parameters, the things given to us. A stone is released from a height of 80 meters. So that means you have a building, maybe a building or whatever. A stone was dropped from that building, and that building is 80 meters or was 80 meters tall. So that's going to be distance along y-axis. Distance along y-axis is also known as height. So we call distance along y-axis, we call it height often. So everything along y-axis is quite different from things along the x-axis. So distance along y-axis is h, which is height. Height is always a meter also. So the height is 80 meters, that's this distance along y-axis. So calculate its velocity just before it strikes the ground. Now, the stone was released from a height of this. So for the fact that the stone was released, you are asked to get the final velocity before it hits the ground. So final velocity along y-axis is what we are looking for. It's unknown. So this stone was released. That means the stone was at rest before it was dropped out. So initial velocity of the stone was 0 meters per second. Initial speed is always 0. Now, note something. If the body is being thrown up, projected up, for acceleration along x-axis, for bodies that are being thrown up or projected into the air from somewhere, the final velocity or the final velocity or speed is always 0 meters per second. We're going to be working on an example to that effect. When an object is being thrown up, the fact is, if you toss an object into the air, that object will not fly forever. So no matter the kind of speed with which the object leaves your hand or leaves wherever it was projected from, the object will not fly forever. At a point in time, gravity will overcome it and it will stop flying, it will stop moving at that speed. The speed will become 0 and it will start dropping back. So for every object at max height, the final velocity for objects along y-axis, that is the final velocity for object along y-axis, is always 0 meter per second. So what are we looking for? We are looking for final velocity. We have acceleration. Acceleration is known already because the object was dropped. So acceleration is plus 10 meter per second squared. The object was released from a height of 8 meters. So we have all what we want. We have our final velocity that we're looking for. We have our distance already stated, 80 meter per second. 80 meter, I mean. We have our initial speed or initial velocity as 0 meter per second because the object was dropped from rest. So what are we looking for this? That's going to be V squared equal to U squared plus 2AS. Now this V along y-axis, U along y-axis, acceleration along y-axis, distance also along y-axis. So distance along y-axis is known as height. So what do we have? We are looking for this V squared. Initial speed 0 meter per second raised by 2 plus 2. Acceleration is 10 meter per second squared times the distance, which is 80 meters. So velocity squared, 0 meter per second squared is just not needed, gone. So 10 meter per second squared, 10 meter over second squared times 80 meter over 1. So what do we have here? We know what we have here already. So this is velocity squared, velocity along y-axis, 2. So we're going to times this 80 times this is 800 meter squared, meter times meter over second squared. That's what we have. So what do we have next? We have velocity squared along y-axis, 2 times this, so 1600 meter squared over this. So we're going to be looking for velocity along y-axis. So this is square root. You know what it is? Loss of indices. Just do this for both sides. So that's going to be square root of 1600 meters squared over second squared. So plus or minus. So velocity plus or minus square root of 1600 is 40. Square root of meter squared is meter per second. So the final velocity is 40 meter per second. That's the velocity before it strikes the ground. So at this point, I'll be giving you some questions to take home. Now look at this first question. A small metal ball was thrown vertically upward from the top of a tower with an initial velocity of 20 meters per second. If the ball took a total of 6 seconds to reach the ground level, determine the height of the tower. Now, acceleration due to gravity for bodies along y-axis is always 10 meters per second. This is a constant. Now, this question was a question given to some JAM students in 1991. So solve this for me and leave the answer in the comment section. So the next we have is a car starts from rest and accelerates uniformly at a rate of 5 meters per second squared. Calculates the magnitude of its velocity after moving through 100 meters. Now, this question was given in 2007 to some NECO students. Now, the very last question, which is very complex, it's not too complex, but quite complex. It will force you to dig deep, is this very one. A stone is projected vertically upward with a velocity of 20 meters per second. 2 seconds later, a second stone is similarly projected with the same velocity. When the two stones meet, the second stone is rising at a velocity of 10 meters per second. Neglecting air resistance, calculate, number 1, the length of time the second stone is in motion before they meet. That's the first. The second, the velocity of the first stone when they meet, at a given point. So this WAEC 1998. So I'd love you to solve all those questions for me and put your answers in the comment section. So at this very point in time, you're going to be drawing the content on today's exposition. So if you found this resourceful, subscribe to this very channel and share this exposition. See you in the next exposition. Thanks.